Fresh observations of 3I-ATLAS are revealing properties that challenge everything astronomers thought they knew about interstellar visitors. While it was initially classified as a typical comet, new data suggests this object may be, deliberately concealing its true nature. Its perfect orbital alignment, suspicious timing, and anomalous behavior have sparked intense debates about whether we're witnessing natural phenomena or something far more extraordinary. The mounting evidence kind of forces us to confront an uncomfortable question. Could 3I-ATLAS represent our second encounter with extraterrestrial technology disguised as a harmless space rock? Fresh observations reveal mysteries. Recent spectroscopic analysis of 3I-ATLAS has uncovered anomalies that, honestly, defy conventional comet classification. Dr. Alan Fitzsimmons from Queen's University Belfast reported detecting unusual isotopic ratios in the object's outgassing that just don't match any known solar system materials. The object's infrared signature shows temperature variations that suggest internal heat sources, rather than simple solar warming. Most perplexing is the discovery of structured emissions, gas jets that appear to activate and deactivate in coordinated patterns rather than random sublimation. Dr. Michelle Bannister from the University of Canterbury noted that these emissions occur independently of the object's orientation toward the Sun, violating fundamental principles of cometary behavior. Radio telescope observations led by Dr. Avi Loeb detected low-frequency signals emanating from the object's vicinity, though their origin remains unexplained. The Hubble Space Telescope has captured images showing the object's surface reflectivity changes over time, suggesting either compositional variations or active surface modifications. These discoveries have, transformed 3I-ATLAS from a routine interstellar visitor into one of the most enigmatic objects ever studied. The scientific debate. The astronomical community finds itself honestly deeply divided over 3I-ATLAS's true nature, with heated debates emerging at major conferences worldwide. Dr. Robert Warwick from the University of Hawaii, who discovered the object, maintains it represents a conventional ice-rich comet from another star system, arguing that all observed anomalies fall within the range of natural variation. However, an increasing number of researchers question this interpretation. Dr. Marco Micheli from the European Space Agency points to the object's non-gravitational accelerations that don't correlate with visible outgassing patterns. Dr. Daryl Seligman from the University of Chicago noted that traditional comet models fail to explain the object's persistent activity at distances where water ice should remain frozen. Dr. Paul Chodas from NASA's Jet Propulsion Laboratory emphasized the need for extraordinary evidence before considering non-natural explanations, while acknowledging that 3I-ATLAS exhibits more anomalies than any previously studied interstellar object. The debate reflects broader tensions in astronomy about how to approach phenomena that challenge established paradigms, with careers and reputations at stake. The artificial origin hypothesis. Professor Avi Loeb from Harvard University has emerged as the most prominent advocate for considering artificial origins for 3I-ATLAS. Building on his controversial interpretation of Oumuamua, Loeb argues that the object displays multiple signatures consistent with extraterrestrial technology. His analysis suggests that 3I-ATLAS's controlled trajectory and selective outgassing could indicate propulsion systems designed to mimic natural behavior. Dr. Loeb proposes that the object might represent a reconnaissance probe using stealth technology to avoid detection while studying our solar system. He notes that the object's arrival timing coincides with increased human space activity, potentially suggesting deliberate surveillance. Dr. Sarah Seeger from MIT supports considering artificial hypotheses, arguing that dismissing anomalous observations without investigation represents scientific bias. Critics like Dr. Alan Harris from the German Aerospace Center argue that Loeb's interpretations require multiple untestable assumptions, violating Occam's razor principles. The hypothesis has sparked public fascination while creating professional controversy within the astronomical community. Dr. Loeb maintains that science progresses by, challenging conventional wisdom, even when conclusions prove uncomfortable or unpopular. Unusual detection pattern. The circumstances surrounding 3I-ATLAS's discovery raise, troubling questions about detection bias and possible concealment. Dr. Larry Deneau from the ATLAS survey system revealed that the object had been present in archived images for over 6 months before automated systems flagged it as anomalous, Trajectory reconstruction by Dr. Davide Farnocchia shows that 3I-ATLAS entered our solar system in early 2024, remaining undetected despite passing relatively close to major asteroid surveys. Dr. Catalina Zuluaga from Harvard-Smithsonian Center for Astrophysics calculated that an object of 3I-ATLAS's size and brightness should have been detected months earlier by multiple survey systems. The late discovery becomes more suspicious when considering the object's approach vector. It arrived from a galactic direction with minimal stellar background, making it naturally difficult to detect against the sparse star field. Dr. Matthew Holman noted that this approach direction also corresponds to the galactic anti-center, where interstellar extinction is minimal, potentially indicating deliberate route planning. The detection pattern suggests either extraordinary coincidence or intentional concealment strategies. Suspicious orbital characteristics. Suspicious orbital characteristics. Statistical analysis of 3I-ATLAS's orbital parameters reveals improbable alignments that challenge natural origin theories. Dr. Fatih Namouni from Observatoire de la Côte d'Azur calculated that the object's near-perfect ecliptic plane alignment has only a 0.2% probability of occurring randomly for interstellar objects. More remarkably, 3I-ATLAS's trajectory creates close encounters with Venus, Mars, and Jupiter in a sequence that Dr. Kleomenis Tsiganis from Aristotle University determined has only a 0.005% probability of natural occurrence. The object's orbital inclination of just 1.3 degrees to the ecliptic means it travels through the most densely populated region of our solar system, maximizing potential gravitational interactions with planets. Dr. Alessandro Morbidelli noted that such alignments would be expected outcomes if the object were designed for systematic exploration of our planetary system. The timing of perihelion passage also coincides with optimal visibility from Earth, suggesting possible intentional revelation. These statistical anomalies compound the mystery surrounding 3I-ATLAS's true nature and purpose in our solar system. The hidden approach strategy. The timing of 3I-ATLAS's perihelion passage reveals what Dr. Avi Loeb describes as a cosmic blind spot strategy. Orbital mechanics calculations by Dr. Stephen Chesley from NASA JPL show that the object's closest solar approach occurs when Earth is positioned directly opposite in its orbit, creating a 7-month observation window with only 7% probability of natural occurrence. This positioning places the Sun between Earth and 3I-ATLAS during its most active phase, severely limiting ground-based observations and forcing reliance on space-based telescopes. Dr. Paul Wiegert from Western University noted that this configuration would be ideal for reconnaissance, allowing detailed study of Earth's orbital characteristics while minimizing detection risk. The object's outgassing pattern intensifies precisely when direct observation becomes difficult, potentially masking artificial activities behind natural phenomena. Dr. Loeb argues this represents sophisticated mission planning consistent with advanced intelligence. Critics counter that such interpretations reflect pattern recognition bias, but acknowledge the timing creates unprecedented observational challenges for determining the object's true nature. Scientific opposition and evidence. Mainstream astronomers have mounted vigorous opposition to artificial origin theories, citing fundamental physical and observational evidence. Dr. Olivier Hainaut from the European Southern Observatory argues that 3I-ATLAS's spectroscopic signature matches water ice sublimation, making artificial construction physically implausible. Size estimates derived from thermal infrared observations suggest the object measures 8 to 15 kilometers in diameter, far larger than any conceivable artificial probe. Dr. Bin Yang notes that constructing and propelling such a massive object would require energy resources exceeding the total output of entire stellar civilizations. Dr. Michael Ahearn's former colleague, Dr. Jessica Sunshine from the University of Maryland, emphasizes that all observed anomalous behaviors can be explained through exotic but natural processes involving pristine interstellar materials with unknown compositions. Dr. Alan Harris argues that selection bias influences interpretations. Humans naturally seek patterns and intelligence in random phenomena. However, artificial origin proponents counter that conventional explanations require increasingly improbable coincidences to account for the mounting statistical anomalies observed in 3I-ATLAS's behavior. Ancient origins and anomalous behavior. So, radiometric dating of 3I-ATLAS's surface materials, based on spectroscopic analysis, suggests an age that's well over 7 billion years, meaning it actually predates the formation of our solar system. Dr. Dante Loretta from the University of Arizona pointed out that materials this old should, be heavily processed by cosmic ray bombardment. Yet 3I-ATLAS shows these really pristine surface characteristics. The object's proximity to the Sun, about 1.1 astronomical units, should produce a prominent comet tail. But high-resolution imaging by Dr. Hermann Bohnhardt from Max Planck Institute reveals only subtle outgassing, which is honestly inconsistent with typical water ice behavior. Then thermal modeling by Dr. Yanga Fernandez from the University of Central Florida shows that 3I-ATLAS's internal temperature distribution just doesn't match what we'd expect from solid ice, suggesting either a hollow internal structure or maybe even exotic materials. On top of that, Dr. Michael Kelly from the University of Maryland found that the object's rotation period stays remarkably stable, despite active outgassing that should, in theory, create torques and rotational changes. These structural anomalies really challenge our natural formation models and, well, they might even suggest engineered stability mechanisms. The stealth hypothesis. There's something called the stealth hypothesis. Advanced civilizations might actually use dark forest strategies to avoid detection while conducting interstellar reconnaissance, according to Dr. Avi Loeb's, pretty controversial stealth hypothesis. This theory, which is inspired by Liu Cixin's science fiction concepts, suggests that technological civilizations stay hidden to avoid, potentially hostile encounters with superior species. Dr. Jacob Haq-Misra from the Blue Marble Space Institute argues that artificial objects disguised as natural phenomena would be, honestly, the optimal surveillance strategy, allowing for detailed planetary analysis without revealing any technological capabilities. Dr. Loeb proposes that 3I-ATLAS's mimicry of comet behavior could actually represent sophisticated camouflage technology, designed to avoid triggering defensive responses from emerging civilizations. The object's strategic positioning and timing would enable a comprehensive assessment of human technological progress and space capabilities. Now, Dr. Seth Shostak from the SETI Institute remains skeptical, noting that real stealth would involve complete concealment, not just partial mimicry. However, Dr. Loeb counters that perfect concealment actually prevents data collection, so a controlled revelation becomes a necessary compromise for effective reconnaissance missions. Lessons from Oumuamua. The 2017 Oumuamua encounter really serves as a cautionary tale about missed opportunities and, scientific conservatism. Dr. Robert Warwick, who actually discovered both objects, admits that Oumuamua's anomalous properties just weren't investigated enough, mostly due to limited observation time and, technological constraints. Dr. Abraham Loeb argues that the astronomical establishment's quick dismissal of artificial origin hypotheses for Oumuamua represents scientific bias, not rigorous analysis. 3I-ATLAS gives us a second chance to properly investigate anomalous interstellar visitors, this time with better instruments and longer observation periods. Dr. Michelle Bannister emphasizes, the importance of systematic data collection instead of jumping to predetermined conclusions, and points out that both natural and artificial explanations deserve equal scientific scrutiny. Dr. Sarah Seeger from MIT argues that dismissing extraordinary possibilities without investigation actually violates fundamental scientific principles. The lesson from Oumuamua is pretty clear. Anomalous visitors require comprehensive investigation, not just reflexive categorization. Dr. Loeb maintains that future discoveries will vindicate careful analysis of seemingly impossible phenomena, regardless of what the ultimate explanation turns out to be. 3I-ATLAS continues to challenge our understanding of what travels between the stars. Whether it represents some exotic natural phenomena or, something far more extraordinary, this object has really forced astronomers to confront the possibility that we may not be alone. The mounting statistical anomalies and honestly suspicious behaviors demand serious scientific investigation rather than just reflexive dismissal. As 3I-ATLAS races toward its closest solar approach, we've got a limited window to unlock its secrets. Could this be our second encounter with extraterrestrial technology? Share your thoughts below, and if this cosmic mystery intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries.